Welcome everyone. In today's analog class, I'm going to explain about how to calculate mu0 into C oxide, which is more important in bias circuit, especially for the current sources, current mirrors, and differential op-amp circuits. So as we know, we know the current equation in the saturation region is ID is equal to 1 by 2 into mu0 into C oxide into W by L and VGS minus VTH squared, right? So when you simplify this equation and try to find out mu0 into C oxide, it gives 2 times ID into W by L to VGS minus VTH. So if you know VGS and VTH, this we can find out from the Cadence Virtuoso tools while simulating. And then for the simplification, I am putting W and L as 10 micro each. Then W by L ratio becomes 1. Then I design a current for 40 microampere, and then the mu0 and C oxide you can easily calculate, right? So let me start designing this one. As usual, open the Virtuoso, say W window and go to the library manager, go to the design, test underscore nmos underscore pmos, and I have already saved the AD state. So in which the DC operating point is enabled. Only the DC operating point is now. Now let's open the schematic. You can see the schematic where the NMOS is in saturation. The gate is connected to the drain, and the source is connected to the ground, and there is a fixed DC current of DC voltage of 1.2 volts with a fixed DC current of 40 microampere. Let's assume that this is the DC source, okay, the constant, the current source. So the current going through in this NMOS is 40 microampere, okay, and the transistor, the model name that I used is NFET 90, and the length is 10 micron and width is 10 micron, okay. So then what you have to do, you have to set up the model libraries and make sure that this model library is contains this NFET 90, okay. So that you can find out, that model name is NFET 90, okay. So now, so I am enabling only the DC operating point. I wanted to know only the DC operating point. Then hit netlist and run. So it will run. So then go to result, then print, or you can say annotate DC operating point. So it will show the VGS and VGS and VDS. Then go to result, print DC operating point. So you can select this, then it will show VTH. You can go down and see here is the VTH 213, right? So that's what I got, this the number from that. So VGS is already printed 0.548, and which VTH is 0.213. WA we already know 10 micron, and L is 10 micron, W by L is 1. Then ID we know 40 micron ampere. So mu0 C oxide you will get it is 0.713 or 713 micro, right? So then if you go to here, beta effective is nothing but mu0 into C oxide, which is also showing the almost same 652 micro, right? Micromole. So this is one of the way how to calculate. So the mu zero into C oxide. Similarly, you can calculate for PMOS. So put the PMOS in the in the bias region, like saturation region, and in the PMOS also you can calculate. The next class I'm going to explain how to design a differential amplifier based on this this technique. Okay, thank you.